next year. So I think the model is going to be maybe 100 times bigger. So what we need to do first is to simplify the model. And this is our idea. It's like recycling. We set a reader here to read the age of the item. If the age is less than 85, the item will go back. Otherwise, they leave. And we also set a reader here to read the information of previous state. Then we will give the item a new cumulative probability. Then we can dispatch the items to particular states by cumulative probability and previous state. Okay, let me show you how we works the program. We just build up all the rules here.
Okay, we use the visual logic in the auction time workstation. We first set the new code in rounding in to the auction time, and then we use the rule in the auction time load in after logic, and then we change the simulation time here several times, maybe 2,000 or even 30,000. This is the table. The first table is the result of model without extension versionism. And we can see when the total simulation time equal to 1,440, the byte time is equal to 198.
Figure 4 shows that a grid-based integrate logistic architecture, and similar to Figure 3. In the beginning, the order arrives, and there are still 3 kinds of orders. But these orders will using the grid concept to divide into the small orders and send to these 4 small enterprises. And each enterprise will do its own job to deliver the cargoes to the destinations.
Is one with the machine sequence like this, machine 1 and machine 2. The sequence of rules by GA is machine 2 then machine 1. If according to international reference, the sequence is machine 1 and the machine 2. In addition, the difficult part of this model to build had many different sequences. So we solve this problem by visual logic.
Of electrical boards, type 1 and type 2. Any electrical board arriving to the production line needs to pass through 4 machines: cleaning machine, insertion machine, welding machine, and inspection machine. At the cleaning stage, type 1 and type 2 are sent to the same cleaning machine A. After cleaning, type 1 is sent to the insertion machine B, and 3 electrical components are installed on the type 1. Similarly, type 2 is sent to the insertion machine C, and the 4 electrical components are assembled on the type 2. After insertion, type 1 and type 2 are sent to the same welding machine D.
I would suggest that if you are doing simulation as a tool, you must look at simulation as a tool. You have to figure out your controllable variables. For example, like yours, the patient volume is a controllable variable, and the physician number is a controllable variable. Okay, and probably you have to also look at the sick bed, the sick bed in the ER. in the emergency department and to see how many resources you have and look at those as your controllable variable. So you run your simulation as comprehensive as possible. For yours, this case, I would say that probably you run you didn't fully utilize simulation because you only run very few cases. This one is for